Good afternoon. We will be talking during the next hour, and I hope it stays within this hour, about JavaScript, the programming language. And since it's always a good idea to explain a programming language by example, I will draw some examples from the Google Maps API. Okay. So as I said, I'm going to talk about JavaScript, the programming language. And yesterday I explained this new architecture of web applications called Ajax, which is actually not so new, but the name is very new, and therefore it was still worth to talk about it. And a central thing in this web applications as we build them today is a scripting language, and this scripting language happens to be JavaScript. And besides being very important for web applications nowadays, it is also a very nice programming language which is not very widely appreciated though. So the central issue of this talk today is basically to explain JavaScript and to explain why it is much nicer than people usually think. And originally I thought that I can kind of teach you JavaScript in an hour, but while preparing this talk, I discovered that it is actually impossible. I mean, you all know that things should be made as simple as possible, but not simpler. So and it turns out that teaching JavaScript as a whole within 1 hour would make things simpler than possible. So still, I try to give you an introduction or an overview of JavaScript, how it feels as a programming language, and basically give you pointers if you are interested in learning JavaScript or in applying JavaScript, where to read more or learn more about the language. And I hope that I can convey kind of atmospherically what JavaScript is about, because it is very quirksome somehow, because it is mostly implemented in very weird runtime environments. Okay, I get into some detail later. And a central issue also is, I think, to lose respect of all the difficulties that surround JavaScript and cross-browser web application development and all that. Okay, so much for that. JavaScript, as I said, has a very bad reputation as being not a serious programming language. Mostly because of the name, because if you look at JavaScript in some detail, it turns out very quickly that JavaScript has nothing to do whatsoever with Java. However, I mentioned yesterday that JavaScript was originally developed not to replace Java as a programming language, but to actually bind Java applets together within a web page. So it was originally developed to script Java and not to replace or to be a script version of Java, which makes much more sense and makes the name being much less ridiculous than it sounds. However, it is actually a quite nifty programming language, which has something like custom objects, function objects, functors. You can create closures, that is, you can create functions dynamically and as closures. You have a much richer literal syntax than Java has, and so on. So on, it has been called a Lisp with C syntax, which is quite right, actually. Google Maps, on the other hand, so the main source for the examples that I'm going to display or to show later, is very widely known as well, I believe. It was launched in the beginning of this year. At the same time, coincidentally, as I happened to start working on it. So when I contributed some of the features that are visible on the Google Maps website. So as I said, it launched in February, later was complemented by satellite images in addition to the maps and merged with the local search property of Google. And by now you can search for businesses, at least in the US and in Canada, on the map and get these displays on the map. And it is widely considered to be the prototypical Ajax application, although this is not literally true actually, because this Ajax stuff is around for a little while. And if you only look at Google, then at least Gmail is also an Ajax application and around for a whole year more actually. Just to give you an example in case you haven't seen it yet, This is how Google Maps looks like. You have this map here, and the nice thing, or the very neat thing, is that everything happens within the page. That is, you can grab the page, and you can move it around and zoom in or zoom out. And this, by the way, is where we are right now in Berlin, near the Alexanderplatz, in this conference center here, which is right here. So much. Oh yeah, and this website, in addition to be the website with this nifty, nice embedded map, also has an API, which means that it is possible to embed this map that we have seen on Google's own website, this map here in the middle of the page, in arbitrary other web pages, which is quite useful actually. So everybody who talks about something that makes sense to be put on a map can now just include a map in his web page and show things that are interesting on a map. So for instance, here New York recently was exposed to a strike of the subway, and it was quite nice because nobody could get in or out of the city. And here's a map that explains how to actually get around in the city and which streets are still open for traffic, which happen to have been not that many, and so on. So this is the map included, or the Google map embedded in a page of the New York Times. And all these additional things here on the map, so these lines and icons and whatever, those are put on this map using this API. So that's what the API is about. So you can embed maps and put things on the map. And in the next half an hour, I'm going to explain how that works. Okay. Let's start to look at the syntax of a typical JavaScript program. Here again is an example using a Google Map, and that's the simplest possible application of this JavaScript API, right? That's an empty web page, and it just contains this map without anything else except the possibility to drag it around. So here's the Alexanderplatz, here's the television tower, and so on. So now I'm going to show you how this looks like. Okay, several things to note. So first of all, JavaScript looks pretty much like Java and C++. So it really makes sense to just describe the syntax in difference to Java and C++. So what you see here are the first thing, or the most important thing, is JavaScript is usually embedded in HTML pages. So it is not, as many other programming languages, you don't run JavaScript by itself, at least as far as web applications are concerned, but instead you embed it in an HTML page. And this JavaScript that is embedded in the HTML page is executed while this HTML page is loaded. And what you here see is the JavaScript is contained in the content of this script element. So there's an element in HTML that is called script, and the content of this element is meant to be JavaScript text that is executed as this element is being read. This text, or this JavaScript code fragment makes this map appear on the page. So what we are doing is we have this div element that is called ID equals map, that has a width and a height, 800 pixels by 400 pixels. And what we are doing is we are creating a Google map around, or that fills itself into this element. And we can do this because we include a JavaScript file right up in the head that comes from the Google Maps website, and that contains basically all the library code that is necessary to do this Google Maps stuff. Okay, and this library exports some objects to us. So JavaScript, of course, is object-oriented. Everything is an object. And what we can do with these objects is, first of all, creating them, and then calling methods on them, setting properties on them. Yeah, that's basically it. And that's exactly what we are doing. So we The next thing to note is actually that some objects are provided by the host environment. So this JavaScript runs in a web browser that contains a web page, and this web browser provides some objects to the execution environment of this JavaScript. So, and one or the most important of these objects is the document. So here's the document. This document is also an object that has a method called getElementById, and this method takes an argument called, well, in this case has the value map. That's the ID of this element. So we get a handle of the JavaScript representation of this div element in the HTML. I mentioned yesterday that the API to talk to an HTML document that is provided in JavaScript is called the document object model, or rather it is a document object model, so it is an object-oriented API to a document format. And in this case, it is the document object model for HTML. So when I mentioned yesterday that the API is quite cumbersome at times. So, but getElementById is a reasonable, well, yeah, kind of a reasonable name, although I would prefer to have it shorter. Anyway, so this gets us a node, a document object model node that represents this div. And this div we pass to the constructor of this Gmap object. And this Gmap object is the Google Map object, basically the object that manages all this behavior, that you can drag it around, that there are map tiles loaded into the div, and many more things, which we see later. It has some methods, and one method is to set the map type. You will see later that the Google Map has different map types, or I actually mentioned that already. So you have a map that looks like a map, and then you have these satellite images, and we don't happen to have maps for Berlin yet. So, and because I want to show this map with Berlin, with the current location actually, it doesn't make sense to show the map mode of the map, which is the default mode, and therefore I set the map type to the satellite map, which shows the satellite images. And I do that using this method setMapType, and this is a predefined constant that I just pass as an argument. The next thing is I create something that represents a geographic location, which is an object of the class gPoint. And these are our geographic locations right now. So that's latitude, and no, that's longitude, and that's latitude. So, and then this map has nicely this method center and zoom, and I just pass the location of the center to the map, and I pass a zoom level. So something that is quite arbitrary, and I just say zoom level 0 is the highest possible zoom level, that is I'm as close as possible. So, and that's it. And that's so much for a very brief overview of JavaScript syntax. So you can look at some of the text that looks pretty much like Java or C++. And to give you a bird's eye overview of JavaScript syntax. So you have seen something like we have control flow statements. They look exactly like C and C++. So we have if, we have for, we have while, we have switch. What you haven't seen is we also have exceptions. That is, you can do the usual exception handling with a try block and a catch clause, and you can throw exceptions that will be caught by the catch clause. We have blocks, that is sequences of statements that are contained in curly braces. We can call functions, and in order to call functions, we use these parentheses, and in parentheses we pass argument lists that are separated by commata. We can deal with objects, and in order to deal with objects, we have particularly this new operator that allows us to create new objects. And also, as we will see later, we have a this keyword that is used inside methods to access the object we are currently executing upon. And we can access members of these objects using the dot operator, which I wrote down here. And later we will see that we also have these brackets that also allow object access, property access on objects. And we can build expressions. So we have these arithmetic operators and Boolean operators, and we have the unary arithmetic operators and the ternary operator and so on. So that all looks pretty much like C++ and Java. So we have here these C++ and Java comments, and statements are separated by a semicolon, which is very nice, except actually, or anecdotically, that you can omit the semicolon in JavaScript. I explained that yesterday, that JavaScript was invented at the time when Netscape, where it was invented, competed directly with Microsoft, and Microsoft had this Visual Basic Script, and in Visual Basic Script, statements are terminated by the new line. So in order to, I don't know, my interpretation is that in order to tease people who are used to Visual Basic Script to use JavaScript as well, they built in this possibility to omit the semicolon at the end of the line, or at the end of the statement if it coincides with the end of the line. That creates endless hassle, and is not a good idea, but it's still in the language. So much for that. The differences are mostly in semantics. So while it looks syntactically much like Java or like C++, it is semantically quite different. And the most notable difference is that it has a top-level flow of control. That's what I pointed out. So when JavaScript is being read, that is embedded in an HTML page, it is executed while it is being read, completely in difference to C++ or Java, where there is no top-level flow of control. So we have an arbitrary entrance point of a flow of control, which is the main function in C++, or the main method, which is a static method in Java. But there is no flow of control going on in the source code that's being written. So, and in that respect, JavaScript is, of course, very much like other scripting languages, like Perl, Python, and shell scripts, and so on. And I also mentioned that it is usually embedded in other types of documents. In this case, notably in HTML. But I still want to point out that actually other document types have document object models as well. And they very often also happen to use JavaScript as their scripting language. So for instance, PDF has a document object model and can embed JavaScript, and Shockwave can embed JavaScript where it is called ActionScript, and so on. Anyway, in this case, it is HTML in which this JavaScript is embedded. And that actually creates, funnily, all kinds of conflicts because HTML has a very strict syntax, which is different from the JavaScript syntax, and it is possible to write JavaScript text down that it is illegal to be contained in HTML. So for instance, these angle brackets or so, which are less than and greater than operators in Java, are not allowed in HTML text, actually. Yet JavaScript appears where normally text appears, so and that creates conflicts which are very tedious and cumbersome, actually, to work around. Other things that we have not yet seen, but will see shortly, are so-called prototypes. So I just talked about creating classes or creating objects and instantiating classes. However, it turns out that there's actually no such thing as classes in JavaScript. And the alternative is called delegation and prototypes. So we delegate method invocations to prototype objects, which are just objects, and these prototype objects act like classes, which is very interesting and very nifty. So I'll get to that shortly. I also mentioned closures and dynamic functions, and well, as in scripting languages, as usual in scripting languages, we have an eval operator, which is also very useful. Back to this embedding of JavaScript in HTML. So I just want to demonstrate where else in HTML JavaScript can be embedded. So first of all, well, we have seen two occasions actually in the first example, so that were files that are referred to by the source attribute of the script element. So that was the first thing that we have seen, this JavaScript library that we include from the Google host. So that's JavaScript that is in an external file that is loaded using the source attribute. So then JavaScript can be contained in the content of the script element that we also have seen. That was basically the script fragment that we have seen. And the next thing I'm going to demonstrate you in a next example. This is again a Google map as we've seen it here. But now we have these two links here, down here on the page, which say zoom out, zoom in. And if I click those, then I can zoom out or zoom in. And I'm going to show you how I achieved that in the source code. Okay, and here are actually two differences from the example that we have seen before. The first difference is that now we are defining a function that contains all our initialization code for this map. So when I explained that this code that is contained in the script element is executed while it is being read. And yesterday, if you have heard this talk about Ajax, I explained that this is actually a wrong thing to do. Because what we are doing there is we access the document object model of this document while it is not yet complete. And this is actually undefined, and you're very lucky if you do this and it works. And in fact, if you, for instance, if we would have done this inside a table in Internet Explorer, it wouldn't have worked. And Internet Explorer wouldn't have told us what's wrong, only that it doesn't work. So in general, it is actually completely undefined what happens if you access the document object model of a document that is not yet read. And therefore, it is better to actually wait until the document is completely read. And the way to achieve that is using this onload event. In general, whatever happens in an interactive application happens as reaction to events. So if you have a graphical or a user interface application or an application with a user interface, then everything that happens in this application basically happens as reaction to an event that is created by the framework using which this application is written. And one of these events that also occur in HTML, so because the HTML document is, so to speak, the framework of our application, one of these events is load, or the load event. And this event is fired or occurs, the lingo for that is it is fired, when the document is completely loaded. So, and what happens now in the script element is that we merely define a function. So, and the script is still executed while it is being read, but what is executed is this function definition. So we have now this function load map, and that does exactly what the script did before directly. So, and this just defines a function. So now we have here this other place. So I'm still talking about places in HTML where JavaScript is embedded, remember? And here's this place, an onload, or an attribute of the body element called onload, and that is defined to contain JavaScript text that is evaluated when this load event is fired. So, and this is just a function call. So the function is called loadmap, and it is invoked using this call operator. So, and what happens now is that this function over there is called when a document is completely being loaded. That is, we can really meaningfully access the entire document object model of this document. Okay, so that's the third place where JavaScript can occur in HTML. A fourth place is so-called JavaScript URLs, which you see here. And that's actually also a very cumbersome idea when JavaScript was invented. Somehow people wanted to execute JavaScript when they click links. So, and a very straightforward and brute force kind of way of achieving this was to define JavaScript as a protocol for URLs. So you know that URLs start with something before a colon, something like HTTP, for instance, or FTP, or mail2, or whatever, and they just defined JavaScript, colon, as a protocol for, or to be used in URLs. And what this means is that whatever follows the colon is a JavaScript expression that is executed in the context of the document that contains this link, but no navigation takes actually place. So this just executes this JavaScript statement. So, and what happens here is if I click on one of these links, then I call the method zoom2 on this object map, and I pass a value to this method that is actually a zoom level, which we have seen before, and this method happens to have another, or this object happens to have another method that gets the current zoom level, or that gets back the current zoom level. So, and what I just do is I zoom to one zoom level up or one zoom level below. So that's zoom out, that's zoom in. So one level more or less. The thing is that these JavaScript expressions are executed in the global context. So that is, yeah, they are executed not inside a function or something, but in the global context of this document, or in the global scope of this document. And now in order to call methods on my map object, I have to retain a reference or to obtain a reference to this map object so that I can call methods on it. And if you look up there, this is what I've done there. So I have this global, I've declared this global variable map and initialized it to null, which is just nothing. And when my onload handler was called, this load map function, at this point, I changed the value of this map object to my newly created map object. So and this actually also makes this code wrong in a certain sense. Namely, if I click on this link before the document is fully loaded, then this expression evaluates or doesn't evaluate because I try to invoke a method on null, which doesn't work because there is no such method yet. Yeah, question.
I have a short question on this onload function. Because I had tested it, I had some strange difficulties with different content types of the HTML file. When I set it to HTML 3 something, it was executed, and when I changed the content type to XHTML, the onload function wasn't executed. Mm-hmm. And Firefox and Internet Explorer, is there something?
No, nothing that comes to mind immediately. You just have to investigate that. But that's just the spirit of programming JavaScript. Yeah. Okay, so much for that. To conclude, okay, I mentioned these 4 places basically where JavaScript can occur in HTML. And just to complete that, JavaScript URLs can really occur wherever URLs can occur. So, and that is meaningfully, of course, only in the href attribute of an A element or in the submit attribute of a form element. However, at least also the img element has an attribute that has a value that is a URL, which is the source attribute. And at least in Internet Explorer, if you put a JavaScript URL in the source attribute of an img element, then this JavaScript is executed, which is not meaningfully at all. So it's really a bug, but that happens. And a 5th place where JavaScript can occur in HTML and related documents are CSS behaviors, but only in Internet Explorer. Yet behaviors are actually a nifty concept, and that's why I mentioned them here. So if you like to read into that, that will be very nice. And next thing, you've seen already how we've defined functions. And I just mentioned that this way of invoking functions in a JavaScript URL that is just put into this link is actually wrong because it doesn't always work. So if I click the link too early, then my JavaScript breaks. So now I have an example where I corrected this. And by the way, I got rid of this global variable, which is also not very nice to have, actually. So you should all know that global variables are evil, and you should have pointed out that to me earlier. So now, let me explain what happens here. We've seen already this load event that is fired on the body element in HTML. Now I'm going to use another event, which is the click event. And what I'm doing now to install my zoom out, zoom in functionality on these 2 links, instead of putting a JavaScript expression into the href attribute, instead I put them into the click handler. That is, if I click on something on a page, a click event is generated. And I can install a JavaScript function or JavaScript expression to be called whenever this click event occurs. So, and that's what I'm doing here, but I'm not doing this in the HTML text as I did it with the onload handler, but instead I'm doing this in JavaScript. So, and that's what happens in these two new sections in the JavaScript code. Let me explain what happens. So I first get a reference to one of these link elements. So again, I call get element by ID. The ID is zoom out, which you see here. That is, what I get is a handle of an object that represents this element in my text, in my HTML document. So, and now this element has an attribute. In this case, or it has an attribute called onClick, and if I have a handle on it in JavaScript, then it also has a property called onClick, so just the same. And to this property, I can assign a function. So you've seen how we defined this load map function, and now I assign to this object another function. However, this function is not static as this load map function. So first of all, it doesn't have a name, and second, it is actually created while I evaluate this statement here. So I have here a function definition that says map zoom to, well, exactly the same what we used to see written here in this JavaScript URL. So it basically does exactly the same. Now, however, this is assigned to the onClick attribute or property of this object. So and what happens is, or it turns out that what happens is, there's a function defined, and this function is an object. So and I can assign this object as a value to properties of other objects. And this is what I'm doing here. So and this event handling magic that is going on in an HTML page defines that if an event occurs, such like a click event on an element, and it has a property that is called onClick, and this property has a value of a type function, then this function is just invoked or called. So, and this is what I'm using here. So I assign this function to this onClick event, and whenever later this onClick event occurs, then this function is called. So now look what happens here actually. So this is evaluated or executed when the document is loaded. So when this load map function is executed. So, and I create this function there, and I assign it to this onClick property, and then I leave the function. So I somehow arrive here, and then my page is initialized, and this load map function returns, and everything is done. So, and this object has a new event handler, which is this function object, and nothing happens until I click on one of these links. So now look what this function actually does. So this function says map.zoom2 and so on. So and here it references map again. So now look what map now is. Map is defined up there as a local variable in this function. So, and other than previously where it was a global variable, it is now a local variable, and local variables go out of scope, that is, they vanish, when the function terminates in which they are defined. So technically, after this function terminates, this map object that I defined up there is no longer around. So, because it's a local variable. Yet, inside this function that I defined here, but which is not yet executed, I access this map object. So, and this is, if you think through it, actually very surprising that this works. But of course it does. So it does work, and this property is not obvious actually. So therefore it has a name. So that's closure. So, and this function is called a closure, and it retains references to local variables in the scope where it was defined. Which is actually a very elegant thing to do. So, questions? Was this understandable at all, actually? Okay. Yeah. Yes. The question was, what happens with the created objects after this load map function terminates? And I'm getting to that actually in a minute. So just be patient.
May I ask another small question?
Where?
Here, right in the front row. The on-click event handler, does it also fire when you activate the link with the keyboard?
I don't know. You have to try it, actually.
Okay. And is it possible to write your code in a way so it degrades gracefully if JavaScript is disabled so that the links don't take you away from the page?
The question was how, if you can write HTML code such that it degrades gracefully. And yes, in principle you can, but in general, if you do more nifty things than just very trivial ones, it is not a good idea. I mean, it's just like writing applications for computers that don't have a CPU or don't have a processor or don't have memory or something. And it doesn't really make sense.
And
so
maybe
you still have to write books instead. So it's like websites and books.
And maybe a small remark, someone earlier asked about XHTML. Try your JavaScript inspector in the Firefox. Maybe it can reveal something, and it's true if you have XML documents, for example, the whole HTML DOM doesn't work anymore and you're lacking a lot of functions, and so you have strange and surprising results and wonder why your JavaScript scripts don't work anymore. So yeah, you really need to pay attention to document types and content types that are sent over HTTP. It's really important.
I didn't understand that at all. Okay. But okay. So what I try to demonstrate is how functions can act as values in this previous examples. That is, I create a function and I use this function not to execute it, but I use it to assign it as a value to a property of an object. And this object is going to do something about it later, such as calling it, for instance. So, and since functions turn out to be values and are objects and can be values of properties, they can, of course, also be returned from other functions. So, and to show you this, I've prepared yet another example, which looks very similar to the previous one, except that I now have this function makeZoom. So, and now again, I'm assigning something to these on-click properties of these link elements, but this time I'm not assigning a function that I create here directly, but instead I assign the return value of another function that I call. So this again is the name of a function, and if I write parentheses after the name of a function, I call this function. So this function is defined here, and it takes as arguments a map object and a number that I call delta. And this number is either 1 or -1, and which is the difference by which I change the current zoom level. So, and what this function does is actually quite funny. It returns a function. And this function does exactly what these other functions that I defined directly over there in the previous example. The difference now, and that's actually quite interesting, is that in the previous case, there was something that is called a reference loop, which means this object has a property that points to something else, which was in the previous case a function, and this function was a closure. And the closure creates references. I explained that a closure retains references to all local variables in the scope in which it was defined. So in all variables independently of which they are accessed inside the function or not. So that is, if I define this function right here, then this function is defined in a scope in which Zi is a local variable. That is, this function would have a reference to this variable Zi, and this variable Zi has a value that has a property that again has a reference to something that has a reference to itself. So that creates a circular reference, which is actually, in general, okay, because that's just very comfortable of the execution environment to take care of that and to still remove objects if they are no longer accessible, even if they have reference loops. However, if these objects that are part of the reference loops contain non-JavaScript objects, that is, objects that are provided by the runtime environment of Java, such as the browser, then this creates difficulty. So for instance, reference loops that contain DOM nodes in Internet Explorer create memory leaks because they are never removed. Even if you unload the page, those objects that are referenced are never removed. So while as in this case, I create a function in a scope where there are only two objects defined, or two variables are defined. One is map and the other is delta. And there is no reference to this DOM node, ZI or ZO or something. Therefore, this function doesn't retain any reference to this variable, and therefore the assignment of the return value of this function to a property of this variable doesn't create a reference loop, which is very important, as I explained. And besides, this idiom or something is called factory functions. That is, you have a function that returns another function. It creates a factory. It creates a function. It's called a factory, and that makes it very clear which variables are actually accessed inside this dynamically created function, which is much better than create them just arbitrarily in a wider scope. So that's a good idiom and very hygienic to do anyway. Okay. Mm-hmm.
Why do you return false at the end of the function?
Oh, okay. This function returns false. The reason for that is that this function is going to be called as an event handler. So now another concept besides events are so-called default actions. So some events in the browser or in HTML have default actions. For instance, clicking on a link usually loads the page that is identified by the URL contained in the href attribute of the link element. So it just loads another page if you click a link. And that's the default action of this click event. And if an event handler is defined for this event, and if that event handler returns false, then the default action is, as it is called, cancelled. That is, in this case, I prevent the click onto the link from loading another page, because that's not at all what I wanted to do. So, and that's why I return false from these event handlers. And besides, what I'm demonstrating here is only one way out of a few others to install event handlers. So that's the simplest possible, and there are other interfaces defined to install events. And I'm not going to talk about that now, unfortunately, because the time is too short anyway to do that. And as I said, I just want to give you an atmospheric impression of JavaScript programming. So, and I can't do much more than this. Okay, objects. I mentioned already that everything is an object in JavaScript, right? And there are several different sources from which object can come into the program. So I mentioned already, though I'm not going to show you much more of that there is a rich vocabulary of literal expressions. So for instance, one way of creating objects is just to enumerate all their fields or properties. So there, this variable point is an object that has two properties, x and y, of which both have the value 1. Another way to create objects is by using the new operator. So I can say new point, xy, whereby point is actually a class that I defined myself. Or I can create built-in objects using the new operator, which is new date, for instance, creates a date object that represents a time, and if I call it without arguments, then I just get the time of now. So that's why I call this variable now. And there are objects that are provided by the host environment. That is, they are not coming from JavaScript itself, but they're coming from outside. So from the browser, in this case, or the document. So we have seen already this get element by ID, which gets us access to an existing element in the HTML page. Or we have such things like create element, which creates a new element, which I can then insert into the HTML page. Okay, and we've seen already that normally, or I mentioned already that normally objects are removed automatically by the runtime environment if they are no longer accessible from the code, so which is called garbage collection. So and there's no finalization as in Java or a destructor call as in C++. And I explained already that this doesn't always work in all cases. Okay, so we have seen already some instances how objects work. Basically, objects are container of properties. So objects have properties, and properties have values, and you can just assign any value to any property of any object. So there's no predefined set of properties that any object can have. You can take any object and just assign arbitrary or set arbitrary properties on it. So I just demonstrated these pair of curly braces is a so-called object literal. So that just creates an empty object. And on this object, I set this property created to now, and I set another property called modified also to now, which is presumably sometime, very short time later. And I can iterate over all objects, over all properties of an object using the in operator, which is markedly different from other programming languages. So I can just have this for loop over all properties in this object X. Okay. I pointed out already earlier that methods are just, or functions are just values, or they are objects, and therefore they can be values of variables or properties. So, and what I just explained is exactly this. That is, of course, also functions can be the values of properties of objects. So, and if a function is the value of a property of an object, then I can invoke this function as a method of this object. And that just doesn't mean that much. It only means that inside this function, there is this special, it is not actually a variable, but it looks like a variable and feels like a variable, this. And the value of this is just the object on which I just called this method as a function. That is, I have this function, which just doesn't look any different from any other function. So, and I just assign it to a property of this object X, which is supposedly just the object X from the previous page, or from the previous slide. So now this property touch of X has a value that is of a type function, and therefore I can call it. And I just call it by appending these parentheses, or by applying the call operator on this value. So, and by that way, I just invoke this method. And if I invoke this method, then I see that the method refers to this. And because I invoked it as a method on this object, this will be X when the method is executed. So that's how methods on objects work in JavaScript. A next very surprising thing is how the new operator works in JavaScript. And again, in JavaScript, as I explained, there are no functions. There are no classes. Still, I can create objects using the new operator. And what this means, I'm going to explain now. The argument to the new operator is actually just a function. So it is just, as we've seen before, we have a function, and we just pass the name of the function as an argument to this new operator, as we do here, for instance. So we have a function called f, and this is an entirely normal function, except that I gave it a name that starts with a capital letter to distinguish it from other functions that start with a lowercase letter, because I want to use this function as a constructor, that is to pass it as an argument to new, but there's really no difference inside the language between those functions. So now what I'm doing is I say new f. So, and what happens if I say new f? There happen three things, two of which I can also express in other ways in JavaScript. Only the third thing is actually the interesting one. So the first thing is I create an empty object, which I can just do using this empty object literal. The last thing that happens is that I execute this object, that I execute this function f with this newly created object set to this. And I explained earlier that functions are objects, and therefore functions also have methods. And one of these methods are methods that actually call this function or invoke this function. And this function apply does exactly this. That is, f apply x just invokes this function as a method of the object x, as I explained before. And now a third thing happens in between, which is very bizarre and very nifty, actually. So a function has a property called prototype. And this I'm going to show you in an example again. Here I defined a function point. And you see this function point takes 2 arguments, x and y. And as you see later, this function has a property prototype. And prototype is just an object. And to this object, on this object, I can set properties. So, and after I call this new operation, like here, like you see here with new point 1, 1. So after I call this, I have an object, and there's, and now it gets interesting. So now this object has actually its prototype set to this prototype property of point, which means the following. Whenever, well, you've seen that I can set arbitrary properties on arbitrary objects. So, and I can also try to read arbitrary properties on arbitrary objects. Now, if I try to read a property from a given object, and this object doesn't happen to have set this property, then the property is looked for on its prototype. So, that is, if I create an object here, something like point, and then I try to read the property toString, for instance, on this object, which implicitly happens if I try to convert this property into a string, which happens if I pass it to this function alert. Then, of course, this object doesn't have any property toString defined on it. So, but it has a prototype, and this prototype has this property toString defined on it. So what happens then is that this property, or the value of this property, is looked up on its prototype. And this mechanism is called delegation. So, and that's the closest what we get to classes in JavaScript. And classes, well, as I said, don't exist, but if we associate a bunch of objects, all with the same property, and all with the same prototype, and then on this prototype just set some methods, then all this bunch of objects has the same method, or at least they don't have the methods, but we can call the methods on them. And this just feels like all these objects are of the same class, although, well, as I said, there is actually no such thing as a class. There's just a common object that method invocations or property accesses are delegated to. The interesting thing is that if I change the prototype property of this constructor, after I've created some objects from it, also these objects will see the modified prototype. That's very nice. So I can create a bunch of objects and then afterwards change their type or change their behavior. Okay, so much for this. Now I have to hurry a little bit because I only have 6 minutes left. Anyway, so much for this. Now back to the Maps API, where we see some more instances of doing this, or of working with JavaScript. Actually, I wanted to make a brief remark about polymorphism and about this idea of calling functions as methods on objects as opposed to have just free functions and passing these objects as arguments to them. You notice that the only difference of a free function that receives an object as an argument and a function being called as a method on an object is that this object is assigned to this inside the function. So if I would just pass instead the object as an argument, it wouldn't matter. So it would just be the same, except I want to do different things on different objects and call them by the same name. So something like toString, for instance. So I have different objects, and on all of these objects I want to call toString. And these objects should do different things or should return different string representations depending on their type. And in that case, this case is actually the only case in which it makes sense to define functions as a method on objects. Okay, so much for this. Let me briefly wrap up because I'm running out of time. The last thing I wanted to demonstrate is that this Maps API, this Maps API provides ways to put things on the map. So, and one class of things to put on the map are controls, which are these things like the things to change the type of the map, to change it to a map or to a satellite images or to both overlaid on top of each other. Then this control to change the zoom level or to pan around. And down here is a scale that is also an object that is put on the map. Okay, just to demonstrate that briefly, the way to do that is to call this addControl method on the map object and pass them instances of different types of objects. And that's actually why I made this remark about polymorphism. Here we have instances or objects of different types that are used in the same way by this method addControl of the map object. So and I have here different objects, and these different objects all happen to implement a function called, or a method called initialize, that just receives the map object, and they do different things. So the map control draws these, well, different types of controls on the map. And that's actually one of the few occasions where polymorphism or calling functions as methods on objects really makes sense. So in JavaScript, there are not that many of these occasions, actually. Yeah, so much for now. It was a little bit tight, actually, and I didn't get to demonstrating events. So just as DOM elements, fire events, also the map object fires events, and these events can be handled. For instance, a click event can be handled by putting things like markers on the map and removing them again. And they can also be handled, maybe? No, that doesn't work. Yeah, anyway, so I didn't demonstrate that, but that's another, or the same way what we have seen with DOM event handlers in the previous case also works on the map object. Okay, so much for now. This is actually it. And though I haven't gotten through all of the things I wanted to explain you, there are even more things that I've left out. And I just mentioned them here briefly. So for instance, I didn't speak about XSLT, which is also a possibility of putting HTML text on the map. And also I didn't talk about built-in types in JavaScript. So you have this type of operator that does a few things for you. I also briefly mentioned exceptions. And I didn't talk much about cross-browser compatibility, which is actually a very nifty and amazing subject to talk about. The main thing to say about it is you just need to lose respect for all of that. Don't be intimidated by all these difficulties, although it all looks tedious if you try to get into it. But that's very adventurous, actually. And the last thing I didn't mention is a very central thing connected with AJAX, which is this XML HTTP request object that is used to transfer data in the background between the server and the page that runs in the browser. Yeah, sorry for not getting to all of it, but as I said, I realized earlier that an hour is not enough to explain a whole programming language anyway. Yeah, there are a few references that I put at the end of the slide set, and I guess that the slide set will be online somewhere at the conference website so that whoever is interested can follow these links there. So much for that. Thank you for your patience and for your interest. And yeah, that's it.